In this video, we'll be looking at how to write equilibrium expressions. From our class notes, we know that if we're given a standard equation of AA plus BB in a reversible reaction with CC and DD as products, we can write a KEQ expression or an equilibrium constant expression by looking at the products divided by the reactants. So in this case, the lowercase letters represent the molar value, the constant, and the uppercase values represent the species or the compound we're looking at. So when we look at taking our products into the KEQ equation, we can see that it's the species, capital C, to the power of its molar constant, in this case the lowercase c. And then we multiply it by anything else on the product side of the equation, and this could just keep going if we had more things. And then we divide it by the concentration of A to the power of its molar amount, multiplied by the concentration of B to its power as well. Okay, so this is our general equation right here, and we're going to use this to write the equations for the following questions. So I'm just going to scroll down here. We'll keep the KEQ on the page for the first question, and we'll get started. Okay, so the first thing we want to do is sort of look at these things, or these species, as separate entities. So there's going to be my A, my B, and my C. Okay, so I have my products, and I have my reactants. So I'm going to start by writing down KEQ, okay, because that's what we're going to try to solve. So KEQ equals, and I'm going to look at my SO3, and I'm going to say SO3, and we put it in square brackets to represent concentration, and we're going to raise it to the power of 2, because we can see 2 as a coefficient in front of SO3. We're then going to divide it, and we're going to put our reactants on the bottom. So I'll do this one in black rather than switching up colors right now. And we're going to take our first reactant, SO2, so SO2, and we are going to raise it to the power of 2 as well. We can see right here there's a value of 2. Okay, and I'll make these a little more clear here in a second. And then we're going to multiply it by the other reactant of O2. Okay, so O2 in square brackets to represent concentration. And in this case, we can see that there's no coefficient. It's just a single 1, so we can just leave this blank. And in chemistry, whenever we have a 1, we can just always leave it blank, because anything multiplied by 1 or raised to the power of 1 is just going to equal the original term. So that would be our KEQ expression for this one, and that's all we have. Okay, so that is the KEQ expression. I'll even make a little fancy for you there. Okay, ooh, lost my fanciness. There we go. So that's that, and the next one I'll do a little more in terms of color coding to help highlight what we're doing here. So let's scroll down to number 2. We're going to start off the equation by writing off KEQ. Okay, that stands for the equilibrium constant. We're going to say equals, and we're going to put our products on the top, reactants on the bottom. And again, this is a ratio. So let's look at NO2 here. Okay, so NO, nitrogen monoxide. So we're going to put NO in square brackets to represent the concentration, and it is raised to the power of 2 because its coefficient is 2. We're then going to divide it. Okay, so we put our ratio symbol in, and we're going to divide it by the reactants. Okay, so the first one I'm going to use is N2. So I go N2, and I put square brackets around to represent the concentration, and we can see that N2 has a coefficient of 1. So I don't have an exponent in this case. And then we're going to multiply it by the second reactant, O2. So I write down O2, put it in square brackets, and again you can see that there is no coefficient here. Okay, so it's just raised to the power of 1. And that's it. That is all you need to do. That is all you need to do to answer these types of questions. Pretty straightforward. That one's not as boxed in as next time, but I'm still learning the software too. And then last but not least, let's look at something that has 4 terms. So again, nice and simple to start off. We start off by writing down KEQ equals. This time I'm going to put in my ratio sign just to get it out of the way. And let's try to color code these as well. So starting with the products. So we're going to start with nitrogen gas, N2. So I write down N2, put it in square brackets, raise it to the power of 3. Then I go on and I get my next species, which is water in this case, so H2O, raised to the power of 4 this time. Okay, we can see this 4 is a coefficient right there. And then it's very important to note that there's a multiplication sign in there, but in chemistry, because we're dealing with two species in square brackets, we know there's a multiplication in there as well. So we don't always show that. Next thing we do is we go on to get our reactants. And in this case, we can see we have dinitrogen tetrahydride. So dinitrogen, H4. We're going to raise that to the power of 2. And then we're going to multiply that as well. And let's see, what color did I get here? Okay, so and then our last reactant here is NO2, so nitrogen dioxide, raised to the power of 2. And we put it again in square brackets to represent concentration. So I'm just going to go back here and clean this up a little bit. And that's it for that question. That's how you answer these. And it's pretty straightforward as long as you remember to always put the products on the top. Okay, so maybe we'll make some notes of these. So remember that products on top. We have to remember that the reactants are on bottom. Okay, so those are on the bottom. We use square brackets to represent concentration. And the exponent, okay, so C to the C, that is from our coefficient. Ooh, sorry for my writing here. This is a little harder than it looks. And that's the coefficient of the equation. Okay, if you can get this down pat, the math part of this is a little bit easier to do. And then once we move into the ICE tables and quadratic equations to solve these equations, we'll have less on our plate. So make sure you practice these, work through all the examples on the assignment. They will save you a lot of time in the future. If you have any questions, please ask me. Have a great day.